right, good evening, everybody. So today what we're going to look at, or tonight I should say, we're going to look at 10.3. So you're going to find lengths of chords, and you're also going to find the arc measures that are formed from those chords. So please make sure you're taking really good notes. You are writing down all of the theorems. You're going through the examples. And with the theorems, please make sure you draw out the pictures and have the equations that go along with it, okay? So feel free to pause at any time and make sure you have this all good to go. All right, so the first one is 10.6. So this deals with congruent corresponding chords. So in the same circle, or you could have two circles that are congruent, you have two minor arcs congruent if and only if their corresponding chords are congruent. So if you look at this picture, if you have arc AC congruent to arc CD, that's in blue, then what you get are their corresponding chords. So remember, the chords are formed from the arcs or vice versa. So just make sure you pay attention to which ones are true, okay, which ones are congruent, okay? So there's that first theorem. Then we have the second one. So this one deals with the perpendicular chord bisectors. Okay, so this says if a diameter of a circle is perpendicular to a chord. So you see that you have the diameter EG, and that is marked perpendicular to chord FD because of that red box, or the 90 degree. Then the diameter is bisecting the chord and its corresponding arc. So in red, what you get is that segment HF is congruent to segment HD, and then the arc that is formed is FD, so I'll dot that in. But the two the two arcs that are congruent because of these chords are, and I'll do this with two tick marks, FG and DG. Okay, so hopefully you can see the corresponding arcs that are formed from that chord, or those two chords being congruent. Okay, so make sure you get that down. All right, the third one is 10.8, a perpendicular chord bisector. We're looking at that, but we're looking at the converse. So now we're just going the opposite way. So this says if a chord of a circle, I don't know why it says on, if a chord of a circle is the perpendicular bisector of another chord, then the first chord is a diameter. Okay, so this says that if QS, and that's what's in red, if QS is the perpendicular bisector of TR, so TR is going to be in green. So in order to know that you have a perpendicular bisector, you have to have two things in the picture. You have to have the right angle, which is given at angle SPT. Then you also have to have the sides that are congruent. So you have TP congruent to RP. Okay, so that tells you you have a perpendicular bisector. So because you have that in the picture, you now know the red segment, the QS, that chord is now a diameter. Okay, so that's just the converse to the previous theorem. Okay. All right, so let's look at this example. Okay, so this says in the diagram below, you have circle P is congruent to circle Q. Okay, it's given in words, and you can see it in the picture because the radii are congruent, the two tick marks. All right, then it also says that FG is congruent to JK. Okay, it's marked in the picture. And you know that arc JK on the right side of this diagram, that's 120 degrees. So you need to figure out what FG is. Well, since you have two congruent circles, and you know two chords are congruent, that means that their corresponding arcs will also be congruent. So JK is 120 degrees, therefore FG is going to be 120 degrees as well. So hopefully that makes sense. Okay, now you do this one. It says in the diagram below, find KH, okay, find what that length is, find what that chord is, and then find the measure of arc HLK. Okay, so try this. Make sure you have all of your work shown, and we'll go through this tomorrow to make sure we're all on the same page with those two answers. All right, another theorem we have is 10.9, equidistant chords theorem. Okay, this just says, in the same circle or in two congruent circles, two chords are congruent if and only if they are equidistant from the center. Okay, so if you look here, we're looking at chords AB and CD. Okay, those are the two chords that need to be congruent. The only way for those to be congruent is if FG is congruent to EG. Okay, and then just one more thing. Pay attention to those right angles. If you are measuring something and you're looking to see if they are equidistant, you better be going straight to it. So you have to make sure that FE and GE are hitting those chords at a 90-degree angle. So if those were not there, I cannot use this theorem. Okay, that's very important to understand. All right, so I want you to go through this to see if you can figure this out. Okay, this says in the diagram EP is equal to EQ. Okay, so it's labeled as 12 and 12, so we can go ahead and actually put the tick marks too if that helps. So EP is congruent to or equal to EQ, and they're both equal to 12. And then the chord CV is equal to 5x plus 7. And the chord BA is equal to 7x minus 3. So what you need to do is you need to figure out what is the radius of the circle. Okay, it is not 12, I'll tell you that right now, because those, EQ and EP, are not radii. Okay, they are just the center to the chord. That's the distance, that's 12. So your answer is not 12. Okay, so try to think about how you're going to figure this out and get an answer for what the radius of this circle is, and we'll talk about it tomorrow, okay? So you might struggle with this a little bit, and that's okay. That's what we want. Try to figure this out on your own. Okay, so that's the end of it. So come with any questions tomorrow that you may have over this, and we will go over those few problems before we look at some examples. Have a good night, and we'll see you tomorrow.